Hello students, now we are going to see the isobaric process. Isobaric process, the thermodynamic process in which the pressure during the system, the pressure during the process remains the constant. Then we can say it is the isobaric process. Now, as far as the graph for the isobaric process is concerned, we can write this is the graph. This is the pressure Pi. This is the PF. Okay, and this is the particular value of volume. And suppose we have defined the isobaric process is the process in which value of pressure remain constant. So there should be only one value of constant which should be remain till the changing the value. Okay, suppose this is the value of the pressure at which the thermodynamic process has carried out, and this is the constant pressure A to B. Suppose A to B, A is the initial state, B is the final state. Okay, now this is the value of pressure at which the entire value has changed from VI to VF. That's why when the thermodynamic process is carried out, when this value of pressure has remained as it is and the process has changed its state from A to B. Okay, so this will be the process, this will be graph, PV graph for the thermodynamic process. Now we will see the exact derivation for the isobaric process. Okay, suppose VI-Ti and the VF-TF are the corresponding values of the initial pressure, initial temperature, and final pressure and the final temperature. Okay, then at that time, how we can write its a work done? How we can write work done? So the work done can be given as integration of P dV from the VI to VF. Okay, integration of P dV. Now, as we know, this P dV means pressure is constant. The pressure will be remain constant. So we can write pressure at the outside. It will be outside of the integration sign. Now what is value? It will be, we can write VI to VF. So this can be written as dV means volume has changed. VF to VI. So this will be your final. When you already put the limits. You have already put the limits. So this one I can write P into VF minus VI. So as we know, PV is equal to nRT. Okay, PV is equal to nRT. So instead of this PV, I can put this nRT. Okay, so it will be nRTF minus Ti. This will be work done. nRTF minus Ti will be work done. Now we have to calculate the value of delta U. We have to calculate the value of delta U. Now, as far as the delta U is concerned, how we can calculate the delta U? So the delta U can be given as NCV dt. Okay. So this delta U can be also written as NCV TF minus Ti. This is the value of delta U. Now, when I apply the thermodynamics law, when I apply the first law of thermodynamics, so I can write W is equal to, I can write in the terms of Q. I will write in the terms of Q. Q is equal to W plus delta U. Okay, so I will put the value of W. What is the value of W? N R TF minus Ti. So this is the value of W plus this value of delta U and CV into TF minus Ti. So this is the value we have put of W and delta U. Now one term you can say which is constant. This is and n is constant, so I can take out in common now. So n into bracket this r into cv, r plus cv, and the remaining term tf minus ti will be as it is. Now as we know that r is equal to this r can be written as cp minus cv. Okay, if you put the value of this r, cp minus cv, then this minus cv and this plus cv get cancelled. Okay, so the remaining term will be only cp. So I can write n cp into bracket tf minus ti. Okay, so this is the value of q, and this is nothing but expression. This is the expression for the isobaric process. This is the expression for the isobaric process.